Okay, fine. Let's start, guys. So, did anybody go through yesterday's class again? Uh, are we good with the concepts, guys? Let me know if you are having any doubts. No? Fine. So, just to give you a recap, we started with the probability distributions. Fine. So, we understood the random variable probability distribution. But mainly, you need to understand just two things. One is discrete variable and the continuous variable. That's all. Everything will revolve around these two things. If given a column or given the data, first you should understand whether it is a discrete or continuous. That's it. And I hope you know the difference between discrete and continuous, right? Yeah. Now, now for the discrete we have seen. Fine. So these are the different types of discrete examples. If we come down, yeah. So I was trying to explain you yesterday. Okay, instead of we doing manually, fine. So we can come up with a function, mathematical function. Fine. Because why guys? Yesterday I have explained this, but I'm explaining it again. See, try to understand. Okay, see, try to understand. What is the simply what is the probability distribution, guys? Okay, simply what is the probability distribution? Just try to understand it again. Okay, because this is important. It is very simple. If you are having a random experiment, okay, from that you will have some outcomes. Okay, outcomes. Let's say outcome 1, outcome 2, outcome 3, okay, so on. For each outcome there will be some probability. Probability 1, probability 2, probability 3, so on. Okay, now this is the general idea. Now if you take the sorry, coin tossing, okay, if you are tossing a coin, how many outputs you will have? Two outputs. Fine. Heads, tails. Agree? For heads there will be some probability, for tails there will be some probability. Cool. If you are rolling a dice, what are the possible outcome, guys? 1, 2, 3, 4, 5, 6. Each of this will have a certain probability. Fine. This is fine. So all these are countable number of outputs. Agree? Heads and tails, 2 we are able to count. 1, 2, 3, 4, 5, 6 we are able to count. Fine. Yesterday I have shown you another example also. Two dice we are rolling. Okay, two dice we are rolling, and we want to find out the probability of the sum. Okay, maximum how many we got? 36 we got. Okay, 36 possible outcomes we got. Out of those, some are same, like 2 is repeating, 5 is repeating, that's fine, but overall 36 values we have got. But still this is also countable, right? And each of it output is having some probability. Agree? This is fine. Okay, but now but the problem here is, what if the number of outcomes are increasing? Fine. How we can find out the probability distribution? If it is 1 or 2, 10, 100, that's fine. Okay, what if the probability, oh sorry, what if the outcomes are increasing? Okay, what if the outcomes are increasing? Fine. So for example, if you see, okay, simply if I take the salary, guys, if I take the salary, okay, now if the, let's say the salary range is between 25,000 to 25k to, okay, 1 lakh. But for simplicity, only only integers. Okay, if I say only integers are allowed, okay, only integers, that means no decimals are, you're not considering decimals. Okay, only integers. Okay, I mean the whole numbers. So how many possible values are there? Is 75,000. Agree? 75,000 values are there between 25,000 and 1 lakh. That means what? 25,000, 25,001, 25,002, like that till 1 lakh. You are having this 75k values. So The number of outcomes are 75,000. Getting number of outcomes are 75,000 outcomes are possible. That means what? Each and every value. Okay, if from 25,000 to 1 lakh, each value like 25,000, 1, 25,000, 2, 3, like that till 1 lakh, 75,000 values are possible. So this is the number of outputs. And for each value, you have some probability. Okay, this is fine. Okay, are we good till this point, guys? Let me know. We'll go step by step. Are we good till this point?
Yes, sir.
Yes, sir.
Okay, but now just in this example only, try to understand the actual salary, not the integers. What will the actual salary? It will also consider decimals also. Agree? It will also consider decimals also. Normally, the rupees will be, it will be like whole number and also decimal, right? So if I consider the decimals also, then from 25,000 to 1 lakh, what will be the number of possible outcomes, guys? There are infinite. Agree? So it could be anything. 25, it could be 25,674.86. Okay. Now this decimal can go can go to anywhere, right? So like that, between two numbers only you will have infinite numbers. So from 25,000 to 1 lakh, you will have infinite numbers. Infinite numbers. Agree? So what does this mean? The outcomes are infinite. Okay. The outcomes are infinite. Fine. So when you try to find out the probability for each and every value of this, it will be closer to zero. Agree? I want to make you guys to understand this point, why it is closer to zero. Because, for example, here you are having 75,000 days. Okay, you are having 75,000. What is the probability of each value? That means what is the probability of 25k? It will be 21, because 25,000 is repeating only once. Okay, 1 by total possible values are 75k. So 1 by 75k. Similarly, any value you take. Okay, for example, you take 60,428. Okay, this is one salary. Okay, only integers. If I consider only integers, this is one salary by overall integers possible between 25,000 to 1 lakh or 75,000. Okay, so okay, sorry, if this is a salary I want, how many times this salary is repeating? Let's say it is repeating 10 times. Okay, it will be 10 by, what are the total possible outcomes, guys? 75k. Okay, so the denominator will always be 75k, because 75k are the total possible outcomes. Okay, if you want to apply the same thing over here here in the decimal part. Okay, so any value you take, okay, any value you take, that might appear one time or two times or 10 times, that's fine. But okay, numerator could be anything, but whatever the denominator is, denominator is what? Denominator is total possible outcomes. Now what is the total possible outcomes?
Infinity.
Infinity. Okay, so something by infinity will be very much close to zero. Getting? So if the variable is continuous, okay, so when you are considering integer, fine, when you are considering integer, that becomes discrete, countable. 75,000, that is countable. But if you are not considering integer, if you are also considering the decimal part of the salary, then that suddenly becomes continuous. That means any value is possible. Okay, so then because any value is possible, the total outcomes will be infinite. So the probability, whose formula is the total number of times that particular outcome is appearing. Okay, let's say this is appearing 10 times. Okay, by total possible outcomes. Okay, that is infinite. So that will be closer to zero. So any value you take, no matter how many times it is appearing in the numerator, the denominator is always infinite, because total values are infinite. So if each and every probability will be closer to zero in a continuous variable. Okay, fine. So each and every probability value in a continuous variable will be closer to zero. Okay, are we good, guys, till this point? Let me know. You understood why in a continuous variable it is coming to closer to 0?
Yes, sir.
Okay, cool. So now how to handle this we are going to see. Don't worry. Okay, but initially try to segregate in your mind what is discrete, what is continuous. Okay, and what will be the probability of discrete and what will be the probability of continuous. Okay, that difference you should have at least now. Okay, now coming back over here. So as I said, just two things, discrete and continuous. Okay, now just now I have, yeah, no, just now I have told you. Okay, this, if the continuous is there, we are having some like closer to 0. Okay, now if we are having 75,000 values, you can find out what is the probability of each and everything 1 by 75k. Okay, in the case of dice you are having 1 by 6, in the case of coin you are having 1 by 2. Okay, but obviously you are having different values, so it is very much useful if you can have a mathematical function. Okay, mathematical function which can give you the probability distribution of this. Fine, yesterday I was showing you the mathematical function, right? Y is equal to f of x. Okay, and that value will be what, 1 by 2 if the coin tosses heads or tails. Okay, like that. So if you can have a mathematical function for each and every distribution, fine, so that can give you the probability distributions. You don't need to calculate like this. Okay, so that mathematical function is simply called probability distribution function. Okay, now since we are having two types of variables, okay, discrete and continuous, so this is also divided into two types. Okay, simple. One is probability mass function, one is probability density function. Okay, probability mass function is what, for discrete variables. Okay, now forget about this continuous variable, we'll come back to it later. Okay, today let's just focus on probability mass function. When we are saying mass function, you should automatically understand that we are speaking about discrete variable. Okay, we are speaking about the discrete variable. Okay, fine. So that is with the PMF, it's called probability mass function. Okay guys, now let's try to understand. In probability and statistics, a probability mass function is a function that gives a probability that a discrete random variable is exactly to some value. Okay, that means this function will tell you what is the probability of a outcome, okay, from a random experiment, provided that provided that the variable is a discrete random variable. Okay, the variable is a discrete random variable. Okay, that means a countable column you are taking, simple words, countable column you are taking, and each of the variable will have some probability. Fine, so that probability you will get from this function. Okay, we will see what is how we are going to get. Okay, so there are two functions, any function, any so wherever you see PMF, right, so just understand it's a probability mass function. Any PMF should satisfy two conditions. The probability assigned to each value should be greater than 0. Obviously probability cannot be negative. Okay, any probability in any scenario it should be greater than 0, and the sum of all probability should be equal to 1. Okay, the sum of all probability should be equal to 1. Okay, that's fine. That is true for any probability concept. Each probability should always be greater than 0, and all the sum of all probability should be equal to 1. Okay, for example, a simple PMF function. Okay, this is also, you can call it as a PMF function. Why? Because this is a single dice is rolled. Okay, so what are the possible outcomes, guys? 1 2 3 4 5 6, you can get one of these. And what is the probability of each and everything? 1 by 6. Okay, so simply I am writing y equal to, okay, 1 by 6. Okay, if x equal to 1 2 3 4 5 6, that means x is what? X is a random variable, guys. We are rolling a dice, x is some random variable. Okay, that means what? Any random value it can take from x belongs to what, 1 2 3 4 5 6, it can take any random value. Okay, that's why it's called random variable. Okay, so but anything you take from, when you're rolling a dice, whatever the value you get from 1 to 6, the probability of that will be 1 by 6. Okay, and 0 otherwise. Fine, so with this function, with this simple function, okay, with this simple function you can understand what is the probability of each and every value from this random variable. Okay, so these are all random variables, and the 1 by 6 is the probability for each random variable. Okay, fine. Are we good, guys? Let me know, did you understand this function? Why it's called a PMF function and how it is telling us a probability distribution?
Yes, Santosh.
Okay, cool. So now we'll see some code. Okay, too much theory. Now let's see some code. Okay, now just remember we're talking about the probability mass function, so that value will be discrete. Agree? So now we'll try to understand how does a probability mass function look like, okay, and how we can generate, okay, etc. Okay, see, for example, let me take a case of okay, let me take a case of rolling a dice case. Okay, we'll roll a dice. Okay, we'll write a code, okay, which will give us what a probability mass function of this rolling a dice. Okay, so for example, let me roll a dice for 1,000 times. Okay, so how we can write it, so we'll try to understand this. Okay, see, um, okay, so this will be for rolling a dice. Okay, so what I will do for I in range of 1,000. Okay, 1,000 times let me roll. Okay, okay, I each time when I roll I'll get some output, right? Okay, so that let me call it as output. Okay, output, I'll take it as a list. Okay, to this output I'm appending what? Random dot rand int of 1 by 6. Why? If you remember, okay, before that I need to import what? I need to import the random variable. Okay, import random. Okay, so why? If you're rolling a dice, the value can be only between 1 to 6, right? So this random dot rand int will always give you value between 1 to 6. Agree? See, no matter how many times you run this, you will get some value between 1 to 6. Okay, fine. So that's why I'm running this experiment 1,000 times, and each time I'm going to get some random variable, fine, that I'm storing into this output. Agree? So now fine, so the 1,000 times the dice is rolled. Okay, so see, these are the 1,000 values. Okay, it has generated randomly. Okay, now let me put it into a series. Okay, so for that you will have in pandas as pd. Okay, so this pd dot series of output. Okay, it will just put it into series, nothing. Okay, it will just tell you, it will give you a series number. Okay, 0 1 2 3 4 5 6 like that. Okay, now I want to now dice is rolled 1,000 times. Fine, now I want to check how much, what is the outcomes of, what is the value counts of each outcome. Okay, that means what? How many times 2 occurred, how many times 5 occurred, how many times 4 occurred, like that. Okay, for that you can use value counts. Okay guys, see, 6 occurred 177 times. Okay, these are the possible outcomes. Okay, and this, okay, this you can simply do sort index. If you do, okay, see, it has sorted in the index. Okay, see, the possible outcomes are this: 1 2 3 4 5 6. Agree? And 1 occurred 157 times. Okay, 3 occurred 173 times, and total 1,000 times we have rolled the dice. Clear? Now if I take the, okay, if I calculate the percentages, okay, if I calculate the percentages, it will be what? Fine. So no, just show you. I also want to, see, so when I'm sorting the percentages, so this is the percentages of each and every outcome. Okay, these are the actual values, guys. This is when you divide by the total sum, you will get the probability. You can call it as probability. Okay, so let me call it as probabilities, because we are discussing about props, because we are discussing about what? Probabilities. Okay, So these are the, so let me just comment this. So see, these are the possible outcomes, all the possible outcomes, and these are its corresponding probabilities. Fine. So to draw a probability distribution, what we need, guys? Outcomes, the corresponding distributions, the corresponding probabilities. Agree? So outcomes you got, their corresponding probabilities. Fine. So if you just try to plot this, okay, if you just try to plot this, okay. Now how you can plot probabilities dot, I'll suggest plot, okay, kind equal to bar plot. See guys, okay, as you can clearly see, okay, this is also sorted 6 1 2 3. I will try if it is variable to, okay, but if I just say props, if I just try to put it into props, yeah, now you got in the order. See, 1 2 3 4 5 6. Okay, so this what we are seeing is the probability distribution, okay, of discrete variable. Agree? These are all discrete variables, countable, and these are the each individual probability. Okay, and this is a graph which we can see. Okay, so this is a probability distribution graph getting of the discrete variable. Fine. So because these are discrete variable, you can use a bar graph. Fine. So we discussed bar graph, bar plot, and histogram, right? Sometime back. Fine. Bar graph is usually used for discrete variables. Fine. For the continuous value, we can go for the histogram sort of thing. Okay. Just giving you a reminder. Fine. So now, because the values are discrete, so we have used a bar graph, bar plot, and you can see the distributions plotted for each and every output. Are we good, guys? Are you able to understand this graph? Let me know. Any doubts also let me know.
Yes, yeah, sure.
You're good, right? Okay, fine. So now what we'll try to do? We will try to okay. Now we will roll 2 dice. Okay. Now we will roll 2 dice. Fine. So when you roll 2 dice, did you remember yesterday when you're rolling 2 dice, what output you got? 2, 12 are having same probability. Agree, guys? And I think 3 and
3, 11.
11 are having same probability. Fine. So like that. Fine. So 2, 12 are repeating only once. So what is the probability will be for 2 and 12? It will be 1 by 36. Fine. For these, it will be 2 by 36. Like that. Do you guys remember? In yesterday's class.
Yes.
Okay. So we'll try to see this. Okay. We'll try to see this experiment. Okay. Using the code. Okay. So simple. You will have an output. Okay. So for I in range of 1000 again. Okay. First dice equal to, we'll take the same. Okay. And second equal to output dot append dot random. Okay. Now sum equal to first plus second. Okay. Sum is a keyword. See, try to understand. Sum is a keyword. That's why it is highlighting in the
Green color.
green color. So that means we cannot use the keyword. Okay, so you can go for the sums. Okay, now what you can do, so you can just append to this output dot append sums. Okay, fine. Now if you just see the output, what, oh sorry, so yeah, why we are appending already. Okay, it is just, first you need to just generate it randomly. Fine. So first you need to generate randomly. Okay, first is you'll get a number. You'll get a number. You need to add those. You will get sums. You need to append that sums. Okay. Next, now let's see the output. See guys, now what is the maximum value when the sum of two numbers? What is the maximum value when you're rolling a die?
12.
36.
36. How? 36? Sirisha?
Okay, 6 plus 6, 12.
Okay, this is the max. What is the minimum value?
2.
Okay, so that's why you see any value over here. So this is sum. Okay, you will see maximum you will find 12, minimum you will find 12, sorry 2, and nothing above or below those two values. Okay, so these are the two numbers. Okay, output is what you got. Okay, so now to this output you can simply again do the same thing. Okay, I want to just do this probability. Okay, probability of each value. Fine, so you will get the probabilities, and if you see the props, fine, so these are the probabilities. And if I use the, okay, fine, if you see the possible outcomes are 2 3 4 5 6 from 2 to 12, and these are its corresponding probabilities. Okay, outcomes, probabilities. Okay, random experiment. Fine, so now now if you see, so if you just plot this, okay, if you just plot this probabilities, now see, see, interesting, what are the values of, see, almost for 2 to 12 you got similar probability. Okay, 3 and 11 will be similar, 4 and 10 will be similar. Okay, 5 and 9, 6 and 8, okay, 7. Getting, you're trying to understand. In yesterday's example I will show you it, because if you want you can generate again, it will give the similar result. Okay, see, now in the yesterday's example, see, in the yesterday's example, first of all it gives idea. Somewhere I have drawn, yeah, so over here. Okay, see, 2 and 12, okay, are able to see 2 and 12 are having 1 by 36 probability. 3 and 11 are having 2 by 36 probability. Okay, why? 3 and 11 are occurring 2 times. Okay, 4 and 10 are occurring 3 times. That's why it will be 3 by 36. Getting guys? So that's why if you see, see 2 and 12 are having that. What is the probability of 2 and 12? 1 by 36. How much is 1 by 36? I don't know. 0.027 something. Okay, somewhere over here, 0.027. Okay, similarly for the other thing, for 4 by 10, 4 and 10 you will have 3 by 36. Okay, like that. Okay, but the graph is interesting. Okay, you're trying to understand, so you can just try to connect this and visualize a graph. Okay, so this is what, this is a probability distribution. Okay, this is the probability distribution again for the discrete variable. Okay, again for the discrete variable, but the experiment is rolling 2 dice. Okay, rolling 2 dice and sum. Okay, so these are the maximum value 12, minimum value, each probabilities. Fine. This is how you can also draw a graph. Okay, is this experiment clear, guys? Any doubts? Are you able to get right what we are trying to do, the experiment what we're taking, and how we are able to generate the graphs? Are we good?
Yes, sir.
Yes, Santosh, but
Yeah.
can you please open that?
Which?
I should have explained, right? So here only 8 is unique, or 8 is equal to 5. Sorry, 6. 6 and 8 should have same
Yes.
5 by 36.
Yeah.
So
Yes. See, randomly. So every time you will not get the same thing.
okay, yeah, that's what I
Randomly,
am.
because see, it is generating randomly, right? So it's not like
Random
every time
basis.
it will generate like 250. See,
Yes,
you
yes,
remember
yes.
this diagram? Now if I run it again, just see. Again, randomly it is taking some other values. Okay. Now the probabilities will change. See, there is
Okay,
slight change.
that's right.
Getting?
Yes. Yeah.
Okay. But it will be more or less.
Yes.
Fine. So see, if for example, let me generate for 2000. Okay. So you see,
Mm.
there is slight change.
Yes.
Okay, now you can see 6 and 8 are somewhat similar. Okay, this is somewhat similar.
Correct.
There will be some ups and downs, but they will be nearby. Okay,
But graph should be same in the
correct,
same.
correct.
No.
Okay, the thing is, the main thing is the probability of 2 will always be less than 3. That's the point. Okay, similarly, the probability of 3 will always be less than 4. 4 will always be less than 5. 5 will always be less than 6. 6 will always be less than 7. Okay, because the probability for 6 to occur, okay, the probability for 6 to occur, okay, 6 can occur 5 times, but 4 can occur only 3 times. Okay, the possibility of getting 4 is only in 3 cases, like when 3 plus 1, 2 plus 2, 3 plus 3, sorry, 3 plus 1 again. Okay, 1 plus 3. But probability to get 6, there are many ways you can get 6. Okay, so this bar for 6 should be greater than bar of 4. Similarly, for 5 should be greater than 4, like that. Okay, fine. So that is regarding the PMF, guys. Okay, so after that, yeah, I hope you're good. Sirisha, you're good, right? You understood, right? Okay, fine. So now that was regarding the probability thing. Now next thing we have something called as cumulative distribution function, guys. Okay, cumulative distribution function. Okay, so cumulative distribution function is nothing but, okay, it's nothing but, so if you remember sometime back we have studied something called as cumulative relative, I think in the first class. Okay, let me quickly so if you see over here, you're having the class intervals. I was showing that this is a frequency. Okay, this is a relative frequency. This is a cumulative frequency. This is cumulative relative frequency. Now, what's the difference? Cumulative frequency will consider that value and also all the values below that. Okay. For example, if you see for 3, it is only 3. Next time for 5, it will be 5 plus 3. That's why 8. Okay. For 8, it will be 8 plus 5 plus 3. That's why it is 16. Like that. So cumulative means just sum of. Even the word cumulative means adding everything, right? So it will tell you, if you ask for 25, it will tell you, sorry, if you ask for 9, it will tell you 9 and also all the possible frequencies less than 9. Okay, that will become 25. Okay, same thing goes for the frequency also. Percentage also it will add. Okay, so that's the cumulative frequency which you have discussed in the first class. Okay, so now if we come back over here, okay, so if you see here also you can find out. So you are having what? You are having heads percentage is something. Okay, tails percentage is something. Okay, and dice for 1 there is some percentage, for 2, 3, 4, 5, 6 some percentage. It's fine. So here also you can try to find out the cumulative distribution. Okay, for these examples also. Okay, we'll try to see for example, if I go over here and this is for the single dice example, right? So for the single dice example, okay, so if I just try to draw a cumulative equal to np, in numpy you have something called as cumulative sum. Okay, sum of what? Of these props. Okay, and if you are using a numpy, first you need to import it. Okay, so come here and do import numpy as np. Okay, fine. Import it. Okay, you got the cumulative, then you need to just plot this cumulative. Okay, see, cumulative distribution will always be in a increasing manner. Why? It will always add. For 3 it will be 2 plus 3, for 4 it will be 2 plus 3 plus 4, like that. Just now I've shown, right? That's why. Sorry. Okay, oh, I think it is showing for the this example because the props value, props is the same variable I have used, right? So I think it is showing for the other example. Okay, we need to just run it again. Okay, so let me run this again. Fine. So now this is the probability distribution. Okay, and this is a cumulative, and this will be the cumulative. Yeah, so this should be the cumulative. Fine. So sorry, if you see here, these are 1 2 3 4 5 6 each individual probability, but here you will have cumulative probabilities. Okay, you will have cumulative probabilities. That means what? For one, how much it was? It was like something around 0.1. Yeah, so the probabilities will be same. Okay, but the scale is different. But here the scale is from 0 to 0.175, so it is somewhere around 0.16 or something. Okay, so same thing, it will be some 0.16 or okay, but for 2 it will be 1 plus 2. That's why you see cumulative graphs are always like this, so it will always be increasing this way. 2 it will be 2 plus 1, 3 it will be 3 plus 1 plus 2. Okay, for 6 it will be 6 plus 5 plus 4 plus 3 plus 2 plus 1. That means what? Probability, adding all the probabilities. Okay, what should be the sum of all probabilities, guys?
1.
1. So that's why you can see here 1. Okay, it's the sum of all probabilities. 6 is the probability of 6 is 6 plus 5 plus 4. All probabilities, if you add here also, if you take add this plus this plus this, all you will get 1. Okay, so this is a way how you can draw the cumulative probability also. Okay, fine. So now similarly you can also do for the other thing also. Okay, cumulative. Okay, now I think I should run it again. Okay, let me run this again. Okay, so let me draw. And these are the, see, now again the graph is a bit different. Okay, so let me, okay, oh, I'm running for 2000. Okay, let me just take 1000. Okay, see, the graph will be sometimes different. Okay, this looks good. Fine. So now this is a cumulative. See, this is a cumulative distribution of the above probability distribution. Okay, 2 3 4 5. So but always remember, for the cumulative, the last one will be 12, will be sum of all the other probabilities. So sum of all probabilities will be equal to 1. So that's why you will have 1 over here. Okay, the range of cumulative is usually from 0 to 1. The 1 will be the maximum value. Okay, so you can clearly see an exponential growth in the cumulative distribution. Okay, this is just called the CDF. Okay, so the one which I have written over here is a cumulative distribution function. Okay, it is just, you can also use PMF plus CDF. Okay, that means what we have done is PMF plus CDF. Agree? So this is PMF, or you can call it as you can call it as probability distribution for discrete variable, or so for simplicity you can call it as a probability mass function also. Okay, it's not a function, but just for the understanding I'm saying, this is probability mass function plus this is its corresponding cumulative distribution for the function of, okay, yep, cumulative distribution function CDF. Okay, so you can do PMF plus CDF. Okay, similarly later we'll see how you can do PDF plus CDF also. Okay, but we'll come back. So this is PMF plus CDF. Fine. So the fundamental line is, for a discrete variable, okay, you can draw a graph which is called as probability distribution for discrete variable. Okay, and the function, corresponding function, is called probability mass function. Okay, probability mass function. Clear? Now, once you have any probability mass functions or probability distributions plotted, you can also plot its corresponding cumulative distributions. Okay, so this is example I would like to show. Okay, for a single rolling dice and for the multiple rolling dice. Fine. Are we good, guys? At least for probability mass functions and probability and cumulative distributions for part. So are we good? So here this is a function. See, for cumulative function, it will be probability of x that will be less than or equal to x. Okay, that means what? If you consider the probability of 5, that means less than or equal to 5. That means what? 5, 4, 3, 2, 1. Okay, all these probabilities it will consider. Okay, so yeah, let me take 5 seconds if you have any doubts till this point.
Fine, Santosh.
Okay, cool. Just give me a second. Fine. So I hope we are good with the PMF. Okay. So now if someone says you they are dealing with PMF, so you should get this idea that we are focusing on the discrete variable and the graph will look something like that. It's a countable numbers and you can also have some CDF for that, etc. and etc. Okay, fine. So now next concept is what is it is for the yeah. So if you go here, we are going to focus over on the probability density function. Okay, this will be for the continuous variable. Fine. So what is a continuous variable? I think you are already you already know till by this time it's a non-countable, infinite possible outcomes are possible. Okay, so now continue probability density function, right? So this actually requires some attention for you to understand. Okay, why? Because now the problem which we are facing with the continuous value is what? If you are taking if you are taking the if you're trying to find out the probability, we understood in the starting of this class that probability of any outcome, okay, outcome one, what we are happening is it is getting almost equal to 0. Okay, almost equal to 0. Fine. So now we'll try to address this. Okay, and we'll try to try to see what all can be done using this probability distribution function, density function. Okay, probability density function. Okay, yeah, don't get confused. Okay, probability distribution function is a general topic. In that, PMF is separate, PDF is different. Okay, yesterday I was saying the abbreviation for probability distribution function also sometimes they will call this is also PDF. Okay, because PDF. Okay, this is also PDF because probability density function. Okay, but in my class, if I say PDF, it is probability density function. Okay, don't get confused. Fine, guys. Now let's start. Fine. So now coming to probability density function. Okay. So this we need to understand in a bit detail actually. Okay. So probability density function. Okay. Here the y variable. Okay. Here the first thing what I'm going to tell you over here is the y variable you are seeing over when you are saying y equal to f of x, etc., etc. Okay. So in PMF, okay, in PMF this y will give you direct probability. Okay, it will give you direct probability. Agree? But here in probability density function, okay, in probability density function, this y is actually not the probability, but it is the probability density. Okay, so there will be few new concepts which you will be studying. Okay, don't worry. Okay, so you will have just some theory. Okay, and then we'll also see some examples. Okay, don't worry. Fine. So you'll also see, sorry, here the probability, the y is not the actual probability, it is the probability density. Okay, now what does probability density mean? Okay, and how we are going to find out, we are going to try to understand. Okay, now see guys, here, because this is a mm, yeah. So because this is a continuous random variable, okay, for continuous random variable, what type of graph we use guys? We usually go for the histogram. Agree? We usually go for the histogram. Fine. So as you can see over here, okay, if this is the plot, okay, if this is the plot, okay, for a continuous random variable, fine. So the important point over here is, if you find out, if you want to find out, okay, if you want to find out the probability, okay, probability of any given value, okay, any given value, the way how we need to do over here is, you need to calculate the area. Okay, if this is a graph, okay, so let's say you are having, this is 2, and now let's say this is 3. Fine. So see, this is 2, this is 3. Fine. So the area between 2 and 3, okay, the area between 2 and 3 will give you the probability that this random variable, okay, will fall between 2 and 3. Getting guys? See, this is a random variable. It can have all different types of outcomes. Okay, so it can have any value. So its range is, let's say, from -4 to 4. Okay, from -4 to 4. So it can range from anything, -4, -3, 0, 1, 2, 3. Any value outcomes are possible. Okay, but since we cannot find out for each and every value, because infinite number of values are possible. Okay, now what we are trying to do, if you want to find out, okay, if you want to find out what is the probability of this random variable, okay, falling between 2 and 3, 2 and 3, here we are going for a range. Okay, in earlier case, what we did guys, in earlier case, in mass function, what we have seen, what is the probability for that coin to be heads, only heads, exactly one value, only tails, what is the probability? Okay, or in the case of dice, what is the probability for it to be 1, for 2, for 3, like that? Okay, specific value. Why? This is discrete variable, you can clearly know that only these values are possible. Okay, that's why we can find out the probability of this particular value. For 1, what is the probability? For 4, what is the probability? For heads, what is the probability? For tails, what is the probability? Okay, but now coming to continuous value, try to understand, you cannot find out the, okay, you cannot find out the probability for each and every value, because there are infinite number of values are possible. Okay, so that's the reason what we will do, we will try to find out what is the probability for this random variable to fall between 2 or 3, getting to fall between this range 2 and 3, and that you will get from the area. Okay, the area will give you the what? So the area will give you the probability. Fine. So any area, so the area between 2 and 3, okay, this will give you the area, will give you the probability. Okay, it will give you the probability. Now there is one important point over here. Okay, but if I want to find out, if I want to find out the probability of exactly that value, only 2 I want to find out. Okay, so if I want to find out between 2 to 3, okay, you can get the area between 2 and 3. Okay, if I want to get between 2 and 4, okay, if I want to get 2 and 4, okay, till here I will consider, okay, this all the area what you are seeing over here, so this much area, okay, that is the probability for this random variable. Okay, what are the what is that random variable, we don't know, what is the experiment they are doing, we don't know, but that random variable will have some outcomes. Okay, but the probability for that outcome to fall between 2 and 4 guys, okay, to fall between 2 and 4 is the area between this graph 2 and 4. getting, tell me guys, are you getting when I say area, or are you losing track? Be honest.
Fine, Santosh.
Others
Yes, sir. Getting.
getting? Okay. See, it is just the area. So, for example, what is the area between -2 and 0, guys? -2 is here. Start from -2. Okay, and 0 is hitting the graph here. Okay, the all the area. Okay, this this complete area between -2 to 0. Okay, this will give you the probability. Okay, probability of what? Probability of, okay, this random variable to fall between -2 and 0. Okay, what is the probability? Because this random variable ranges from -4 to 4, guys. That means sometimes it might be -4, sometimes it might be -4, -3, -3.5, -2, all any value that is possible between -4 to 4. We don't know how many times, how many values are falling between -2 to 1 or -2 to 0. We don't know what is the distribution. Okay, but what I'm telling is the area will help you to find out the probability. So you can tell if this area, okay, if this area is, let's say, 0.6. Okay, now 0.6 sorry guys, now 0.6 is the probability for this random variable, okay, for this random variable to fall between -2 to 0, -2 and 0. Fine, just like how I said, 0.5 is a probability for the hit, for the coin to toss as head or toss as tail. Just try to correlate with this. Okay, this is one random variable outcome. So to get heads or tails, this is a 0.5 is a probability. Similarly, for this random variable to fall between this range -2 to 0, to fall between this range, this is a probability 0.6, and that is the area. Okay, the area will give you the probability over here, because we cannot calculate each individual value probability because of the infinite possible chances. We are taking the help of the area. Okay, so in the continuous variable, the area will give you the probability values. Fine, but now as I said, okay, if it is between 0 and 2, okay, I hope now if I ask you what is the probability for this random variable to fall between only 0 and 2, okay, if to fall between only 0 and 2, okay, you can find out this area. Okay, how you can find out? Integration will give you a area. Okay, you don't need to do all integration, but just the concept is, if you integrate this graph, okay, from 0 to 2, okay, so see, integration of a to b, okay, from 0 to 2, f of x, this each distribution will have a function. Okay, we will see that. Okay, each distribution will have function. Okay, if you integrate that function from 0 to 2, okay, if you do the integrations, you will get this area. Fine, now that area is simply the probability. Okay, that area is simply the probability for this random variable to fall between 0 and 2. Okay, that's fine. But my question is, if I want to find out the probability of specific value, I don't want a range, I want to go for a specific value 2. Just tell me what is the probability that this random variable will be equal to 2. Okay, 2 గాడానికి probability enta for this random variable? Is the question clear, guys? I'm not asking for the range.
Yeah, so do we need to subtract different areas
No,
to
how
get
you separate different areas? You can tell me the ideas, guys. Because if it is between range -2 to 2, you'll consider this range. Okay, all this area is up. You'll just use this integration. You will say integration of -2 to 2. If this is a function, if this function is simply, I'm taking some example. Okay, y3 plus y2, some 2y square, okay, some plus 6. If this is a function of this graph, okay, and if I ask you the what is the probability that the random variable will be falling between only -2 to 2, it should not be less than -2, it should not be greater than 2, it should be only -2 to 2. So you can just integrate, do some integrations, and you will get some value. Okay, let's say 0.04. So that means 0.04 is a probability that this random variable is falling between 0, 2 and 2. That's fine. But now if I'm asking for only 2, okay, what is the probability that it will be equal to 2? Okay, now what we can do here is, there is a small trick. Fine, so the probability of 2 is, okay, for 2 what we'll do, we'll calculate the area between 2 and 2.00001. Okay, 2 and 2.00001, which is almost equal to 0, but you'll have two different numbers. Okay, to calculate the area, you need a range. Fine. To do the integration, you need a range, lower value and upper value. Fine. But if you're trying to check for only one particular value, the probability, you don't want the range, but still you can use this formula by creating a range. Okay, this is artificial we are creating, but this works. Why? It is almost closer to 2. 2.00001 is extremely less when compared to 2. It is almost equal to 2. Fine. So the probability, if you want to find out the probability of only 2, fine. So you can integrate this function between 2 and 2.00001. Integrate this function, you'll get certain value. That is the probability that this random variable will be equal to 2, almost equal to 2. Okay, I cannot use the word exactly because you are taking 2 and 2.00001. Okay, this is almost 99.99999%. It is just equal to 2, but it is not 100%. Obviously, if you speak strictly logically, it is not 100% because this is 0.00001 error. But for all practical cases, that small error is not going to affect. Fine. So you can just use this way. For -2, if you want, you can take -2 and -2.00001. If you calculate the area between these, you will get the probability for 2. Getting, guys? Did you understand this point? For 2, see this. If this is for 2, what will be 2.00001? I can't draw also. See, it will be extremely closer to 2 only. Okay, that means indirectly you are getting the probability for 2, which is our goal. Okay, so here I'm just repeating. So here in the case of probability density function, we are going to use the area under the graph. Okay, and the area under the graph is always going to give you the probability. Okay, so technically you can call it as a probability density. Okay, this is, you can call it as a probability density. Okay, but you can consider this as a probability which you are getting from the graph. Okay, so for example, if you have 2 to 0, you can just take this area and consider it as probability, because that is a value, probability value, which you are going to get it using the integration part. Fine. But if you want to specifically want for a particular value, you can just use this small trick. Okay, this is nothing we are doing anything wrong. This is just a trick we are using so that we are going to get it's exactly for 2 what is the probability. Fine. Now similarly, now just like our random experiment 1 2 3 4 5 6, you can calculate the value for 5. Here also you can calculate the 5 by 5 and 5.00001. Okay, so the area under this 5 and 5.001 is giving you the probability of 5 in a continuous random variable. Is this clear, guys? Let me know any doubts.
Clear, Santosh.
Sirisha, Meghana?
Clear.
Honestly, clear? No, if you don't understand,
Yes.
you can tell me, because
Clear.
I understand, because this is the first time you're learning. So even if you don't understand for the first time, that's completely fine. Don't feel anything bad. Okay, but it's clear, right? Okay, cool. So I hope you understood the difference, how we are dealing the probability density function, how we are dealing the probability mass function. Okay, mass function is a bit easy. Okay, because you have only fixed values and you can simply find out the distributions. That's fine. But coming to density function, right? So density function will be continuous. So in continuous, because of the infinite number of possible values, you cannot go and sit and calculate each probability value. That's why you are using the concept of area under the curve. Now, area under the curve using the integration part will always give you the probabilities. Okay, and for the each value you can use this small value. Okay, so now see here it is a probability density and not the actual probability. How to calculate the probability? The probability will give you will get it from the area. Okay, now there are few examples for the continuous function. Okay, the probability density function, as we have seen here, normal distribution, chi-square, etc. In this, normal distribution is the extremely important and very famous distribution. Okay, I think tomorrow's class and every class after tomorrow you will be constantly touching this normal distribution. Okay, this is very interesting, very simple, and also very important normal distribution. But one important thing now I think you can understand is normal distribution is this PDF or PMF? Normal distribution?
PDF.
PDF, fine. So PDF, one of the example of normal PDF is normal distribution. We have another distribution like Poisson distribution, etc. also. Okay, but normal distribution is one distribution. Okay, so yeah, that's all for today. So I will just show you. So tomorrow we will discuss how you can actually you know draw a probability density function. Okay, I'm saying this graph. Okay, but how you can actually draw and how you can understand more in detail probability density function. Okay, you will understand. So then you will have clear understanding of PMF and also PDF. Okay, then we will try to go into different types of PMF functions and different types of PDF functions. Okay, the reason why we are trying so much spending so much time and trying to understand these are most of 90% of the stats is this. Okay, this is about the distributions, just this distributions. What are the different discrete distributions, what are the different density continuous distributions. Okay, so now as I said, normal distribution is one of the PDF function. Fine, so if I just show you normal distribution. Okay, if I see probability distribution, so if I just show you probability distribution. Okay, so there might be different types of probability. Yeah, so as you can see, there are different types of probability distributions. Okay, for example, here if you see, okay, if you see here, see here you have Bernoulli distribution. So we will see in later classes, but Bernoulli distribution is a discrete distribution. So if it is a discrete, is it PMF or PDF?
PMF.
PMF. Okay, so if you see here you have Bernoulli distribution. Okay, so you can go here. Okay, clearly you can you see here probability mass function. Okay, this is a PMF function. Okay, and each function will have some each distribution will have some function. Okay, because this is a probability distribution, guys, and it will come under probability mass function. Okay, this is a Bernoulli distribution which will come under probability mass function, because in this distribution we are considering only what discrete variable. You can see discrete probability distribution of a random variable. Okay, so that distribution you're trying to understand, right? Using discrete variables you can create many distributions, not only Bernoulli. Okay, you can the random variable might be discrete. Using that you can create multiple distributions. One of the distribution is Bernoulli distribution. Okay, and because this is discrete random variable, the function is called PMF, probability mass function. Okay, and each distribution will have its own function. For example, if you see yeah, so this is a function. Sorry, this is a function. Okay, q equal to 1 minus p and p. Okay, we will see this when we are studying this. Okay, see, this is a PMF of this. Okay, and this is CDF of this. Fine, mean, median, everything what all we studied, skewness, everything will come into picture. Okay, getting? So, and if I just show you similarly our normal distribution. Okay, see, normal distribution, just now I have shown you normal distribution is what? It's a PDF, and if it is PDF it is continuous. Okay, so if I show you, see, this is normal distribution and it is probability density function. See here PDF. Okay, and these are distributions and these are the cumulative distributions which we'll see. But the main important thing is if it is a PDF, okay, obviously, see, this is a continuous variable. Same concept. It is a continuous variable. Using continuous variable you can have many types of distributions. Okay, you can normal, Poisson, chi-square, etc. All these distributions will use continuous variable. Okay, one of type is normal distribution. Because it is continuous variable, the function we call it as PDF. Okay, probability density function. Clear? And if this is a function, so obviously each type of function will have its own function. Okay, see, for normal distribution the PDF function is this. See, the PDF function is this. Okay, this is a function 1 by rho square root of 2 rho e to the power of 1 by 2 x minus mu by rho square. Okay, don't get scared by this formula, simple formula, but this function, this is a formula guys. Okay, this formula is what? It is the probability density function. Fine, that means what? It will give you the probabilities. Okay, just try to understand that. Okay, so just like how you are drawing this graph and taking the area and calculating the probability, now the importance of this function is this probability density function, and this is what? PDF for what? PDF of normal distribution. Okay, this is formula for only normal distribution. But if you go and see some other normal distribution, what was an other normal distribution guys? Poisson distribution. Okay, so if you see, you have here Poisson distribution. Okay, so this is okay, Poisson could also be probability mass and density function. Okay, so if I see some other Pareto is what? Yeah, Pareto is probability density function. Okay, so for this, that the function will be different. See, for this the PDF function is different. Okay, just try to catch the difference. Okay, so these are all probability density function is just a function for that particular type of distribution. Okay, so for normal distribution, this is a graph. Fine, and this graph will give you the probability. That means what? If you give a x value, okay, if you give the x value, it will just give you the probability. That is importance. You don't need to do all this. Okay, so you for the distribution, you just need to give the what is the standard deviation, what is the mean. Okay, row mean. I hope you remember this standard deviation mean. Okay, so if you not, just revise those concepts. Okay, so if you just give these values, and here if you see the x, whatever the x you are seeing over here, okay, whatever the x you are seeing over there, okay, that value, if you give x, right, it will calculate this formula and it will give you the value. That is a probability for that particular value. Okay, how you are doing from the area, right? So you can also have the function for this normal distribution. That is called the probability density function of the normal distribution. Okay, and this is the formula. Fine. So as I said, normal distribution is one of the extremely important in the probability density function concept. Okay, tomorrow we are going to see, and before that we are going to see actually how you can draw probability density function. Okay, fine guys, that's all from my end actually. So I hope the class is clear. Okay, you might have slight confusions here and there, but I don't think we did not go anything depth. Fine. So as I said yesterday, try to go through the class once again. In class you might understand 100%, you might feel, but if you just go through the class, right, so it will be more clear, and start making notes. Fine. So that's all from my end. Are we good guys? Any confusions? Okay, cool. So I'm going actually very slow. Okay, actually we can complete these in 1 or 2 classes, but because these are extremely new concepts, right, so I'm taking some time and going slow so that you will have fundamentals very strong. Okay, so after that we will cover other distributions. Okay, fine, let's meet tomorrow and try to discuss more on this probability density function. Okay, chalo, thanks guys, thanks for joining.